Hello, let's continue our Sudoku adventure with Don't Juneau, Don't You Know by Calvinball. All right, so we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have killer cages in the grid. So the way these work is we have cells surrounded by dotted lines. Those are our cages. The digits in the cage sum to the value in the top left. So these three would sum to 8. So we could do, for example, 1, 2, 5. 1 plus 2 plus 5 is 8. That would fulfill this cage. Not the only way to do it, obviously. In addition to that, digits can't repeat in a cage. So normally Sudoku would allow me to put say a 2 here and a 2 here. Then we could put a 4 here and finish off our 8 sum. But repeating the digits is not allowed within the same cage, and so that would be disallowed. That limits our sums in a way that makes them easier to approach. And it sometimes adds some geometry deductions. All right, well, there is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so we talked about killer cages recently, but this is really showcasing the sort of minimums and maximums that you can think about. So for a 3-cell cage, we know that digits don't repeat in cages no matter what. So in a 3-cell cage, the minimum we could put is 1 plus 2 plus 3, because we can't repeat digits. Can't do like 1, 1, 1. And that adds to 6. So the absolute minimum a 3-cell cage could add to is 6. And because that's the minimum, that's the only way to do it. So that adds to 6. Now, thinking about the 7, we could start with 1, 2, 3. That adds to 6. We need to add 1 to that. So how do we add 1 to the sum without adding any more digits? Well, we have to take one of our digits and we have to add 1 to it. So we can't add 1 to the 1 because then we'd have 2, 2, 3. That would repeat the 2. We can't add 1 to the 2 because then we'd have 1, 3, 3. That would repeat the 3. So the only digit we can add 1 to is the 3. So there's actually still only one way to add to 7, which is the 1, 2, 4. Now if we look at the 8, if we start with our 1, 2, 4, the only way to add to 7, we need to add 1 to that. Now there's two options. We can add 1 to the 4 to make it 5, or we can add 1 to the 2 to make it 3. So what this is telling me is that we are 1 through 5, but we always contain the 1. So we can actually mark that 1 is in here and 1 is in here, definitely. Now I'm noticing that we have some lineups here. So we know that the 6 contains a 1 and a 2, and the 7 contains a 1 and a 2. So in these two columns, that uses up all our 1, 2s. Now a consequence of that is that this has to be a 1, 2 pair, right? I need 2 1s and 2 2s in these cells, and there's only 2 columns. And so this can't be 4 and this can't be 3, because this needs to be one of the 1, 2 pairs and then another 1, 2 pairs over here. Because we can't put more than 1, 1 or more than 1, 2 over here. And in addition to that, we don't get any more 1, 2s. And so these are all not 1, 2, meaning this has to be a 1, 2 pair. And that places a 5 here because 1 plus 2 is 3, and we need a 5 to get to 8. Now we also have these 1s lining up. That's all of our 1s for these 2 columns. And so these can't be 1, meaning the 1 is placed here. And that gives us our 2 and our 1. All right, we should probably look at this 6, because 1 plus 5 is gone. There's only 2 ways to add to 6. There's 2 plus 4, and there's 1 plus 5. 3 plus 3 doesn't work, because we can't repeat. And so that's 4, and that's 2. Now this 6, this also can't be 1, 5. Because if it was 1, 5, what would this cell be, right? If we tried to do 1 plus 5, this wouldn't have any option to be 1 or 5. So this 1, 5 looking at that cell is enough to remove 1, 5 from here, meaning this has to be 2, 4, and this 2 tells me that's 4 and that's 2. So that can't be 2 now. So now we know this 8 cage doesn't have a 2 in it. So the minimum I can put in 2 digits is 1, 3, which adds to 4. And so then the only option is then to add a 4 to that in order to get to 8. Because if we tried to do 1, 4, that would add to 5, and that just means we add the 3 to it, right? So the 3 was the only small digit I can put in. And 1, 5 would require the 2, which we don't have. So anyway, there were only 2 ways to add to 8, right? There was 1, 2, 5, and 1, 3, 4, and without a 2, you can't do 1, 2, 5. So that's our 4. This is a 1, 3 pair. This is just, yeah, this is 5 and this is 6, because of that 5 there. This is a pair. This is 3, 6. And that means this is 1 and this is 3. We get our 3 here, 1, 2 pair. And this is 5, 6. This 6 tells us that's 5, that's 6. Right. That 1 looking down places the 1 in our 8 cage. And this should be 2, 5. Yep. This is our 2, 4, and 1. This is our 1 and 2. That's 5 and 2. This digit here is a 6 for the column. These two digits are 3 and 4. This 4 tells us that's 3, that's 4. So this digit is 6. Up here we need a 5 and a 3. All right, need a 3 in this box, which goes somewhere here. So we need a 4, which goes here. Now this is the 3. Now we need the, let's see, 6 and 3. That's 5 and 6, and we're done. All right. Nice puzzle, Calvinball. Kind of guiding us on, hey, here's our very small 3-cell sums, thinking about how those work, but then also thinking about how these line up. And I like how this forced the 1-2 pair. I think that was neat. That, you know, we couldn't put a 3 or a 4 over here because it had, we needed to use a 1 and a 2 twice in these cells. I like that logic. And then doing it again over here with just the 1s. Cool. Well, let me know how you did. And if you enjoyed this, want to leave a like, subscribe, and a kind comment below.